Hello everyone and welcome back to our channel Quaint Cosmos. Today's topic of discussion is post-quantum dilithium. So dilithium, this term is there. What is dilithium? Dilithium is a lattice-based cryptographic algorithm. Yes, dilithium is not a crystal from Star Trek. Okay, it's actually an algorithm, special type of algorithm. It is crystal-based algorithm. Actually, here in the development of this algorithm, crystal mathematics was used. So, what is the requirement of developing this dilithium? So, requirement is, quantum computers are there, Shor's algorithm is there, which is very fast. Okay, and problems are there. Today's means current encryption method use what? They use RSA encryption techniques, and ECC is also there. ECC means elliptic curve cryptography. So, they actually based on what? They actually based on mathematical puzzles like factoring huge numbers or solving discrete logarithms. Mathematically they are huge. Okay, so classical computers, it is very difficult for the classical computers, whether it is a normal computer or a supercomputer, for them to break that thing, that encryption is very difficult. They would take actually millions of years to break the same thing, millions of years. Okay, so RSA and ECC, those things, those encryption techniques are okay with classical computers. But with quantum computers, no, those are not okay. Because quantum computers are exponentially faster than classical computers. So if hackers or the attackers use quantum computers, they can easily break that RSA encryption technique or ECC encryption technique. That means what is the requirement? A requirement is the development of a new cryptographic technique. New cryptography is a requirement. And that's why scientists have developed so many techniques, and out of those things, one is most famous, and that is known as dilithium. Okay, dilithium crystals kyber is there, that is used actually for what? Encryption. Crystals kyber. And CRYSTALS-Dilithium. Whenever I am saying dilithium, that means it is actually CRYSTALS-Dilithium, and this is used for what? This is used for digital signature. Digital signature and electronic signature, both are different things. Anyway, in a separate video, I'll make the distinction. Okay, I'll discuss the distinction between electronic signature and digital signature. Anyway, so for digital signature, this technique is the requirement. This technique means dilithium technique. We are talking about actually future technology. Quantum computers are coming very soon because there is a rapid progress in the field of quantum computing. Anyway, so to attack or to prevent our present systems from quantum attackers, okay, future quantum attackers, we are developing, means scientists are actually developing this dilithium encryption techniques. So this is the main requirement. So here also mathematics is being used, but this mathematics is different from that factoring huge numbers or solving logarithmic problems, okay, discrete logarithms. This mathematics is totally different. This is known as a lattice mathematics. Even quantum computers can't break this. That's why scientists are calling this as a unbreakable digital handshake. Scientists are calling this way. Okay, and dilithium is no longer an experiment. Okay, it has already been accepted by NIST, means I am talking about that in 2022, the USA National Institute of Standards and Technology, they declared their dilithium Okay, they officially actually declared dilithium as their standard, as the global standard, not only standard, global standard. NIST has accepted, or better to say, they have declared dilithium cryptographic technique as the global standard. Anyway, so now you know the importance of dilithium, and this video actually I am making just to discuss the importance of dilithium, and it is really unbreakable because quantum computers also can't break this within seconds. You know, if you make comparison between classical computers and quantum computers, actually quantum computers thrive on parallel computation, and for certain tasks difference is huge. For the same task, quantum computers might take just few seconds, and the same task could be solved by the classical computers. That would take a much higher time, millions of years or billions of years. Anyway, so that means what? That means quantum computers are not villains actually. Okay, don't consider quantum computers are villains. They are coming because the requirement is there. Many things are there which can be solved only by using quantum computers. Many problems, many global problems are there. Okay, but with that good thing, the bad thing is also coming, and that bad thing is what? That bad thing will be used by actually hackers or the attackers. So to prevent all those things, scientists are already experimenting with these things, and you know the tech giants, Google, IBM, Cloudflare, already they are experimenting with this thing in different systems like web browsers or firmware updates. They are experimenting with this dilithium. Okay. Anyway, so this was all about today's topic. So what is the difference between this dilithium and that RSA and ECC? Mathematics actually is totally different. Mathematics is totally different. And that is the advantage. Again, a source algorithm is also being used. This is very fast, you know, source algorithm. So that means it becomes fast as well as quantum resistant. Quantum resistant means even quantum computers can't break this. So we can say that this dilithium is becoming the backbone of next generation of quantum safe internet security. Next generation of quantum safe internet security. Yes, it is going to become, better to say it is becoming, dilithium is becoming the backbone of next generation of quantum safe internet security. Okay, and one more thing is there. So this is actually comes from a family known as crystal suit. Two things are there. One is a CRYSTALS-Kyber, which is used for encryption, and CRYSTALS-Dilithium, which is used for digital signature. What is actually digital signature? What is the importance of this? How these are used? Those things will be discussed in a separate video. Anyway, whether it is digital signature, in case of digital signature, private key, public key, these terms are there. So these things will be separate, will be discussed in a separate video. Okay, that will be better for the audience, I think. So anyway, so this was all about today's topic, and this is the end of this video. If you found this video fascinating, so please like, share, and subscribe to our channel. This is the end. Thanks for watching.